Hello everyone, greetings and welcome. I am Komal Das and along with my project partner Pujashree Kashyap, we are going to give a brief overview about our final year project that is done under the guidance of Dr. Lachit Datta Sir, Professor Kandarpo Kumar Sarma Sir and under the co-guidance of Dr. Surajit Deka Sir. The topic of our project is Biosignal Monitoring System, especially for senior citizens in rural areas. So these are the outlines of the project and I will start with a brief introduction about the project. So let me introduce what a biosignal means. A biosignal is any signal in living beings that can be measured and monitored. It is designed to track and analyze psychological signals from the human body. A biosignal commonly monitored heart rate, oxygen saturation, body temperature, etc. Now, speaking of the motivation of biosignal monitoring system, it addresses the challenges associated with the healthcare domain of IoT. It is advanced in the technology, especially in the field of information technology and computing power of processors. The real motivation is to save the time. Here are some of the literature review that we have gone through. This is the block diagram of our project. So as we can see that we have used three sensors that are temperature sensor, ECG sensor and pulse oximeter sensor which is connected together with the ESP32 microcontroller with a 3.3 volt power supply. Then we use a USB cable as a Bluetooth or Wi-Fi module which is connected with the IoT. For the interconnection between doctor and patient, we design a website which is linked with the IoT. So let's talk about the problem formulation of the project. So in phase 1, we design a multi-sensor monitoring system with ESP32 and Arduino IDE, and in phase 2, we design a real-time multi-sensor data monitoring and analysis system in IoT and website interface. Here we mention the methodology of the project. So now let's focus on the hardware that we have used. MLX90614 sensor. It helps to measure temperature. MAX 30100. It helps to measure heart rate and blood oxygen saturation level. AD8232. It helps to measure ECG, which can be used for monitoring heart activity and detecting abnormal cardiac rhythms. Arduino IDE, an IoT platform. It provides an intuitive interface for writing, compiling and uploading code to Arduino microcontroller. So this is the block diagram of multi-sensor monitoring system with ESP32 and Arduino IDE which we have done in phase 1. Here we take three sensors ECG, pulse oximeter and temperature sensor separately which is connected with the ESP32 microcontroller with a 3.3 volt power supply, and the ESP32 is linked with the Arduino IDE platform to analyze the data from the sensor. This is the pin connection of temperature sensor MLX90614 with ESP32. By placing our finger some distance from the sensor, it will detect the temperature of our body. Here's the result we have got. This is the pin connection of pulse oximeter sensor MAX 30100 with ESP32. By placing our finger in the sensor, it will detect the heart rate and saturation oxygen level. And here's the result we have got. This is the pin connection of AD8232 with ESP32, where we use electrode patches which is placed in the human body, where yellow patch is placed in the left side of the chest, red patch is placed in the right side of the chest, green patch is placed in the lower abdomen in the right. And here is the result we have got. In phase 2, we focused on integrating the ESP32 microcontroller with the sensors we have used in phase 1. Additionally, we designed a website to visualize the sensor. Here we mention the steps involved in phase 2. This is the block diagram of sensor interface where ECG sensor, pulse oximeter sensor and temperature sensor are connected with ESP32 microcontroller. and their data acquisition and processing is carried out in Arduino IDE platform for identifying normal and abnormal readings. And for the data transmission between patient and doctor, we design a website which is linked with the IoT. Identification of temperature ranges into normal and abnormal. The normal range of body temperature for adults is typically considered to be around 36.5 degrees Celsius to 37.5 degrees Celsius. Here we mention some guidelines for temperature categorization. And here is the result we have got for temperature identification. Identification of pulse oximeter into normal and abnormal ranges. Here we mention some general guidelines for categorizing pulse oximeter readings. Here is the result of pulse oximeter identification. Identification of ECG signal into normal and abnormal. Here are some general guidelines we have mentioned to identify the ECG pattern is normal and abnormal. Here are the result of ECG identification. This is the pin connection of the integration of the biosignals that we have made, where we connected all the three sensors together with the ESP32. And here is the real hardware setup image that we have made. And here is the working result of ECG, pulse oximeter and temperature together. As I said earlier, we design a website that allows user sign up, data upload, data visualization, admin login, and doctor-patient interaction. Here we mention some following steps which is used to design the website. We use Visual Studio Code and Node.js platform for designing the website. So this is the user sign up page where the patient have to fill up their personal details to create a new account. After that, a new web page will be opened where the patient have to upload his data about his or her heartbeat, pulse rate, oxygen, temperature and the ECG report. After the successful uploadation of the data, he or she can log out the page. After that, the admin can log in the page and see the data uploaded by the patient, and after checking the data, the doctor can upload the report of the patient by writing or uploading the report. After relogging the account, the patient can check the report uploaded by the doctor to get their health update at home. So the biomonitoring system offers several key conclusions like improved healthcare access, early detection of health issues, enhanced safety and peace of mind, personalized healthcare management, cost-effective healthcare, empowerment and self-care, data-driven healthcare research. Now let's see some of the future work of our project. We can add more sensors, automatic data transmission to the website, disease classification with ECG and implement of GSM. These are some list of our references. That's all from our side. Thank you.